In this lesson, we're going to talk about conditional probability and the general multiplication rule. So, conditional probability, our notation is the probability of E, and then this vertical line means given F. So, we're finding the probability that event E occurs given that F occurred. So, our formula for that is the probability of E given F is you find the probability of E and F and divide by the probability of F. All right, so notice the probability of, it's the probability of the given part that goes in the denominator. So to find that, we're taking the number of times that E and F occur and dividing by the number of times that F occurs. All right, so let's take a look at this example. Use the table below from a survey done in Professor Bilas's algebra course regarding pet ownership of students. Okay, so first we have this table. It could be called a two-way table or contingency table. We're going to fill in the totals. So if I fill in the total for dogs, 42 plus 19 would give me 61. The total for cats would be 42. The total for birds would be 14. And then if we find our total of male students, that would be 60. And our total female students would be 57. So together, if you add 60 and 57, you get 117. And that's also the same if you add the 61, 42, and 14 together. So here we are going to compute the probability that a randomly selected student owns a bird. So we're finding the probability that a student owns a bird. So we're going to take the number of students who said they have a bird and divide by the number in the sample space. So if you look at your birds total, that would be 14. Over the number in your sample space, that would be 117. And that's approximately 0.1197. Part C here, compute the probability that a randomly selected student owns a bird given that they identify as a female. So now we are finding the probability that a student owns a bird given that they are a female. Okay, so for this one, I'm going to use the formula just to practice that, but then when you have a table, you don't necessarily have to use the formula, and I'll show you how that would work out. So the probability that the student owns a bird given that they are female, we're going to take the number that have a bird and are a female and divide by the number of females. So, looking at the number that own a bird and is a female would be 6. Out of the total number of females would be 57. That's approximately 0.1053. Okay, so again, when you're just looking at the table instead of writing out the formula, you're thinking, okay, what's the probability it's a bird given it's a female? Well, I know it's a female, so I know there's 57 students. Out of those 57, 6 own a bird, and that's how we get to our 6 over 57. Part D, compute the probability that a randomly selected student identifies as female given that they own a bird. So now we're finding the probability that the student is a female given that they own a bird. So we're looking for the number of students who are female and own a bird. And we're dividing by the number of students who own a bird. Well, the number of students that are female and own a bird is still 6. But this time we knew that they owned a bird, so that would be out of 14. It's approximately 0.4286. So again, female given they own a bird. So you're looking at those who own birds. That would be 14. Out of those 14, 6 students are females. All right. Example 2 here. Among 200 households surveyed, 110 have high-speed internet, 38 have a landline phone service, 128 have mobile phone service, 27 have high-speed internet and landline phone service, and 31 have landline phone service and mobile phone service. Of those with mobile phone service, 80 have high-speed internet. What is the probability that a household will have high-speed internet given that it has a landline service? So, we are finding the probability that the household has high-speed service given that they have a landline. So, following the formula, we're taking the number that have high-speed and a landline, and we're dividing by the number of what is given, which is having a landline. So, if we look here, the number that has high speed and a landline, so that would be 27, have high speed internet and landline phone service. And then also we need the number that have a landline, and that would be 38 have a landline phone service. So we would take 27 out of 38, which is approximately 0.7105. All right. Second objective here is figuring out what the general multiplication rule is. And this would be if we have, it works if we have independent events too, but we've talked about independent events, and there is no, one does not affect the other. So if you know something about what happens, it doesn't affect the other one. So this is really for dependent events, but can be used for both. There is an error here down in the gray box. It should say, this right here, it should say the probability of F given E. And then the book makes the same mistake at the end. That should say the probability of F given E. Okay, so let's take a look at that. Here is our conditional probability rule. If I'm trying to figure out what is the probability of E and F, then I would simply multiply both sides by the probability of F. So we could write that the probability of E and F, or E intersect F, would equal the probability of F, so the second thing, times the probability of E given F. Okay, same thing for what's right here. They just decided to write it using the probability of the first thing. Okay, so it just kind of depends on what you know. So the probability of E and F would be the probability of event E times the probability of F given E. If we were finding the probability of E and F, it would be probability of F times the probability of E given F. So just different notation. Okay? Well, let's do an example using that. So we have our internet usage example here again, but this time we are asked, what is the probability that a household will have high-speed internet and mobile phone service? So we are finding the probability that a household has high-speed internet and mobile phone service. Okay, so remember, that's the same thing as saying the probability of high-speed intersect mobile phone service. So we're going to take the probability that they have a mobile phone service times the probability that they have high speed given the mobile phone service. All right, so the probability of mobile would be the number that have mobile out of the number in the sample space. And then the probability that they have high speed given they have mobile would be the number that have high speed and mobile, or intersect mobile, divided by the number who have mobile. So the number that have mobile would be 128, and the number in the sample is 200, times the number that have high speed and mobile. Let's see, right here, of those with mobile phone service, 80 have high speed internet. So that's going to be 80 out of the number that have mobile, which is the 128. So if you multiply those together, you get 0.4, which is 40%. Okay, now, let's see here. Really, because we didn't have to use that formula in this one, because we are given the number that have high speed and mobile. That's the 80 out of the 200 total. If you take 80 divided by 200, you also get 0.4. Okay? So the note here at the end is two events, E and F, are independent if the probability of E given F is just equal to the probability of E. And same thing, if the probability of F given E is equal to just the probability of F, they're independent because what is given doesn't matter. Okay, so knowing the condition didn't change the probability, so the events are independent. Okay, so knowing the condition didn't change the probability of the event, so the events are independent. Okay, so if you're asked, if you're given probabilities and you might be asked, are the events independent, you could check mathematically to see if they are or are not. Okay, so that's the basis for conditional probability and the general multiplication rule. I'm going to upload some additional examples. Please watch that video if you feel like you need to see some additional examples.